Hello, everybody. Thank you for coming to our dynamic website hosting or web app hosting workshop on AWS. Today, the speaker is my good friend and fellow UT Austin computer science student, Jack Roper. He's like AWS God, real OG. As usual, if you, and another thing, this workshop kind of builds on some of the workshops that I had done earlier. So if you attended my S3 workshop or my Flask workshop, this workshop will show how to mix those two technologies and host Flask instances on EC2. So that way you can access your Python apps online. So there's a little fun fact for you. As usual, if you have any questions, please feel free to drop them in the live chat on YouTube, and then I will happily ask Jack on your behalf. Alternatively, if you have questions afterwards, then you can just message Jack or you can just message me on Slack, and I will go ahead and forward the question along to him. Anyway, thank you for coming, and Jack, go ahead and take it away.
Yeah, sure. Before we start, I'm going to be actually creating a few things and showing you how to do it. So just for this thing, you're going to need an AWS account, some SSH client, and some way of editing files using command line. If you can use Vim or Nano, that's fine. If not, there's this extension for Visual Studio Code, which allows you to like type stuff in over SSH, and that's super handy. But yeah, all right. So EC2. EC2 stands for Elastic Compute Cloud. It's this service that by AWS that'll rent you out computing resources like memory, CPU time, cores, all that sort of stuff. It actually doesn't rent out storage, which is mildly important because you'll figure out when you're setting it up and you're like, why can't I access or have any files? But yeah, that's what it is. It's just rentable storage or rentable computing power. So when you set up EC2 instances, you just go to your AWS console and just go here. And it'll show you this. We'll go to running instances, and we're just going to launch a new instance. So here we go. So we're going to try and keep almost everything in this tutorial free so that you can set it up at a hackathon. First thing you get to choose is an image. An image is basically just what your instance is going to look like when it's booted up. So it includes the operating system, maybe some software libraries. Get an instance that comes with a SQL server. You can get an instance that comes with Windows installed. We're going to do the most boring basic one and just pick regular Linux 2 AMI. And this is just plain Linux, nothing installed, nothing else on it. And choose an instance type. All this stuff, there's a million different types of EC2 instances. You can get stuff that is really, really small, only one CPU and almost no memory. Stuff that is absolutely massive with like 96 gigs or 96 cores, 786 gigabytes of memory. Fortunately, that costs money. I don't really like to spend money, so I'm gonna just pick the free one. All right. These are a bunch of settings that you can edit for your EC2 instance. So you can create like more than one. You can do this thing, which makes it so that your instance only runs like when it's really, really cheap, but then it doesn't run at all. Most of these settings are actually automatically configured for you. You can check the information to see what each of these do. But it's important just to make sure that this thing is on some setting that says enable. And that will give you a public IP. If you're not sure, a public IP is what allows anyone else on the internet to actually access your website. If you don't have a public IP, no one can touch it. So you need a public IP. Next thing, you have to actually add storage to your instance. Like I said earlier, instances don't actually come with storage. They're just computing and memory. So you have to attach storage to it. Fortunately, Amazon's also willing to charge you for storage. They have this thing called EBS or Elastic Block Storage. We get 30 gigs for free. I'm only going to use 8, both because it's the default amount and because this tutorial is really, really tiny. Yeah, so you have to add storage to your EC2. You also add tags to it. These are just helpful for you to look at if you ever want to do something like, oh, what was this thing again? Purpose, and then like, oh, this is for the hackathon. You don't need to add that. It's purely optional. This stuff is only ever going to be read by you for the most part. And then security groups. So what this thing does is this defines all of the ports that go in and out of your server. So if you don't know what that means, that's like all the different kinds of connections your server is allowed to host and where they're allowed to come from. So right now it comes with this default rule SSH. So this allows you to SSH into your server from this block of IPs. And this 0.0. This giant string of zeros means all IP addresses are allowed to access our instance. So that means anyone will be able to SSH to it. But don't worry, you'll only be able to SSH into it if you have the key, which we're going to get in a second. No one else will. And we also want anyone to be able to access our website. Right now, no one can actually see the website because we don't have a rule allowing people to see it. So we're going to say via HTTP, which is on port 80, anyone can look at the website. If I wanted like a specific person to look at the website, I'd be like, oh, so this person at 12.3. This giant string of letters, only they can access it. But we don't want that to be the case. So we're just going to do the default, everyone can see HTTP rule. So you can see the general stuff in the slides. Make sure that's enabled. Add any amount of storage you feel like. You don't have to touch the tags unless you feel like it. Make sure you add HTTP. You can also add HTTPS. That's usually what you do for web servers, just so you can add encryption. HTTP is the web's like transfer protocol, and HTTPS is the same but secure added onto the end. Our web app isn't going to be secure. It's actually going to be super leaky, but you can add that on, and we'll just review all the details. So it'll show you, yeah, we're getting the free one, getting the free image, the free size. We're allowing someone to access our website over HTTP and HTTPS, and we can access it on SSH. And yeah, this stuff looks good. We're going to hit launch. All right. So for this one, I'm just going to create a new key pair, but this is a key pair. This is the special like key that allows you to go into your instance and actually mess around with the stuff inside it. Anyone who has this key, it can edit the stuff in your instance. Do not lose your key. If you lose your key, you will not be able to access your instance. You'll have to recreate the whole thing. It's a mess. So, and you can notice it says that right here. You have to download this file before you continue, store it, and secure it. You will not be able to download it again. Don't lose the key. All right, hackathon key, and let's launch the instance. It works, it works, it works. Yeah. So we've got this giant, let me move this over here. So the instance right now is launching up. You're going to notice we have a public IP, which is very important. And this is what's going to be the address where people can actually access our AWS instance. So while that launches up, it's not going to let me. Oh, it's up. Okay. So you can right click it to see this menu of commands you can do. You can stop it, you can reboot it, you can shut the whole thing down permanently. That's what terminate is, but we're not going to do that. We're just going to try and connect to it. So here's where your SSH comes in. You can actually do it through the browser, but that's a lot of pain. So I'm just going to use an SSH client. So we have our hackathon key. We have to change its permissions so that we're allowed to edit it. So let's go, let's chmod 400, and it's in downloads hackathon key. So you follow the instructions here and allow you to actually access it. And then copy this. All right. Since we've never connected to this before, our computer is going to be a little worried, but I trust that Amazon is secure. Permission denied. Hold up, that's never happened. One moment. To be honest, I've never seen this issue before.
You're using the right key, right?
Reboot this. Yeah, absolutely. This thing's hackathon key.
Oh yeah, that's the one. Weird.
All right.
Oh, do you need the quotes?
Try
Maybe
one more
that's it.
time. Oh my
There you
God,
go.
how did that?
It's because you have
wacky.
double
All
quotes
right.
or something.
All right. Well, on that note, after that, we've got to install some stuff on this little box that we have running so that we can get this working. So all Amazon instances come with this package manager called Yum. So it allows you to just install stuff doing this, Python 3. Yes. And while it's installing that, then we're just going to make a folder for the server. We're going to move into the folder. We're going to install Flask as root. And we're going to create our first, our application Python file. So now Flask is installed. Okay, our server. Move into the folder. And then create the file. All right. So here is our super simple server code. Flask just allows us to find these things called routes. So these routes define when the user goes to this section of the website, they are sent back this certain request. So on slash, which is the default root of the site, we're just going to have this function get called. I'm just going to turn the text a website. And at the very end of this, we're going to have a file that says if we're running this file, or some lines of code that say if we're running this file, run the app, allow anybody into it, and run it on port 80. Remember actually from earlier that we opened up port 80 so that other people could access it. That's why we're doing that. So I actually have that copied right there. So again, so we import the Flask library, create the app with the name of the current file. And when someone accesses the index, or someone accesses the default root, we're going to return the words a website. And then when we run this file, we're going to actually create the web server. So let's do sudo python 3, run it as a module app. All right, running on the default port, or the default IP is address 80. So how do we access it? We would go to our IP that we have earlier. And because this is public, we can actually look at it, which is pretty handy. And just paste it in there. And ta-da, we have a website. This thing. You notice it actually gives you a log. Someone decided to get slash that root using this function, and we return 200, which means it worked. If I refresh this 1, 2, 3 times, 1, 2, 3 more times, I got it. You can see anyone who accesses it here. Yeah. But of course, typing in this big string of numbers isn't really fun. And it's not really good if you're like, oh, I'm google.com. Oh, what's google.com? Well, I got to type in like this giant string of numbers. It's not really handy. So instead, we have to create something called DNS. Now, DNS is called a domain name. Well, the S changes depending on who you ask, but it's either a domain name system, server, or service. What it does, it turns URLs into IPs. So DNS server is just something that takes this, says, oh, I have a lookup table. I know what google.com is. That leads to this IP. And just to make sure everything doesn't overlap, there's this big organization called ICANN, which basically manages what every single possible website name and who it belongs to and how to contact them and where it leads. Being a corporation, they charge people to actually register these domain names, which is inconvenient because I don't like paying for stuff. But Amazon is actually willing to basically give it to us for a cheaper price if we go through their thing called Route 53. So let's go back to our Amazon console. Route 53. So Route 53 is this thing where Amazon will basically say, look, you still have to pay money, but we will create this domain name such as texassummerhacks.com. Check if it's available, and oh my God, it is. All right. Normally I'd add this to cart and type in all my credit card information here on a live stream, but I'm not going to do that. fact, I've actually already bought one. So normally once you buy one, you actually have to pay for it. You have to wait a few days for it to get approved, and then finally they'll get back to you like, yeah, you know, your domain name is good. We've registered it for you and all that. So once you have a domain name, we're going to use this jackroper.info one. You go here, and you'll normally start out with these two record sets. You start with this one and this one. These are kind of like metadata. You'll notice you actually can't delete them. It's technically impossible. These things show like just metadata about the domain name. Like if I go to any of these servers, they'll tell me that jackroper.info is somewhere else. And this is a domain server that basically claims that they're telling the truth. You don't need to worry about this. Amazon has already set this all up for you. But you do need to tell it where to actually point. So I'm going to create a record set. And I'll open up a thing on the right-hand side right here. There we go. So we're going to have no alias. And actually, let me open this in a new tab so I can pull up the EC2 instance. So we're going to create the record set that says every single time we type in jackroper.info. And this is actually what I use for recruiters, but I doubt a recruiter is looking at my site right now. It's a bunch of different types of these. Every time I type in jackroper.info, it's going to lead to this IP. Going to create it, and voila. So if I run my server again, and now I go to jackroper.info, ta-da, it's a website. So if you're actually here for Ansh's talk, another cool thing that you can do with this is you can reroute this stuff to a static S3 bucket. So I have an actually S3 bucket where I host like a personal site. So I've got this like, oh, I want it to route to an S3 bucket. You can do the same thing. And it's taking a second to update. Oh, I forgot to save. All right, well, most of the time you would normally be able to do this. This isn't quite important, but it's another possibility. For now, we have that thing loading in. And I stopped the server, which is why it couldn't be accessed. All right, what's next? So right now we have a static site, which means every time someone queries it, they get the exact same thing. This is kind of lame. They could basically download the website to their computer and get the exact same thing, which kind of sucks. I'm gonna reroute this back to the EC2 just so you all can see it in action. All right. So we're going to actually create this thing called a route, a dynamic route. So Flask has a lot of capabilities, and this is one of them. So let's open up the app code. So now we have this different thing right here. We have an app.route, hello, and then we have in this brackets, which means that's a root variable. So every time they go into root, every time they do hello/something, that's going to redirect to this root right here. So, and it's going to call this function hello name. You can see it's a super simple one. You can probably guess what it does, but just in case, we're going to try and access it. All right, so there's our index. Let's do /hello. Perhaps I typed something wrong there. Oh yeah, one more thing. Forgot to copy that. Use that for markup, safe, import, escape. One thing that's also important is that you have to escape your characters, or else you might face some security vulnerabilities when people try to type stuff into your, people try to access stuff in your website. There we go, hello world. And I can do hello test. I can do hello Texas. Looks pretty simply. And obviously this is a dynamic site now. You couldn't store a giant list of every single word in the English dictionary and then just serve them to them when the client requested it. We're actually having to assemble the web page the second they ask for it and then send it over to them. But of course, right now we're just sending over text. That's kind of lame. We should probably do some HTML and CSS. Fortunately, we can do that. So you might be wondering how we actually use HTML while still passing in variables to it and assembling it on the fly. And they have this thing called a templating language, which they call Jinja. Jinja is just like a version of HTML, but it allows you to do lots of conditionals and lots of if statements and lots of fancy stuff like that. It's also natively compatible with Flask, so you don't really have to change anything about your application or import anything. So Flask will find any templates that you put in the folder called templates, find any static files in the folder called static. So static files are things that don't change from request to request to request. For example, every single user is going to have the same CSS style sheet, or every single user is probably going to be accessing the same, script.js or the same images, So in that case, got a fake template here that I have to open with the command line. Actually, I'll just use source. And I'll put it into here. As you can see, this looks kind of like HTML. You have the title, it's going to link to a spreadsheet, but then you've got these weird double brackets here. And that just signifies that this is a variable that's going to be passed into the template. This variable is actually the path to all the static files and then style.css. And we have a conditional here. If name, then we do hello name. And if there's no name, we do hello world. And we end the if. That looks kind of weird. So let me show you what the actual script is going to look like. Let's delete all this, paste in the next iteration. So one important this extra field called render template. That'll allow us to actually render the templates, and Flask just comes with that natively. Here's what we got. Every time someone accesses hello template slash or hello template slash name, we're going to call this function with name having the default value of none. That way, when you call this thing, no name is none. And every time someone accesses any of these routes, we're going to return hello template.html with this variable passed in. So you check that, and you check template slash hello template.html. Notice, oh yeah, we're passing in name right here. So, or we're using it right there. And then let's also add that style sheet that we said we were importing in this thing called static. So we've got this style.css. We're going to put in static, which and of course, Flask will automatically detect anything you put in the static folder. So if you want to put images, style sheets, that's where you put it. And let's launch the app and see what happens. See if we have any bugs. There we go. And we go back to jackroper.info. We still have this route. We still have the default route. Let's go to hello template. Hello world. Blue, because it's an H1, and we styled it blue with the CSS. We use something, summer hacks. And that's an if statement that we found in the template. So every time we call one of those routes, it's taking that template and it's dynamically like compiling it into HTML and then sending it over. So each one of these is just a brand new HTML file that's generated and then destroyed on the fly. Well, that's one way of thinking of it. All right. Last thing that dynamic sites allow you to do is SQL. You can actually access like databases, anything you can do in Python, really, you can do in this dynamic kind of server setup. One of the most handy things you can do is access a SQL server, which allows you to have like user data and logins and whatnot. You'll notice this is kind of big, so I'm going to explain what a lot of these lines do after I paste it in. All right. So we're importing SQLite 3. That's just a library for SQL stuff. We're also importing this thing called G. For some reason, Flask actually does have a thing that allows you to open and close stuff dynamically. So when the web server is running, it'll open up the SQL database. When it closes, it'll automatically close the SQL database. But for some reason, they put all that stuff inside of a single letter variable. I don't get that, but it's fine. All right, we're good. This is where our database is going to be. So we have a function called getDB, which will get the attribute of this giant G function, this G import, which automatically detects where your database is. It's none. It'll connect to it, and then it'll return the database object. Now, we have an initDB, which will set up the database and give it a table called users. So every time you want to access a database, you have to say with the context. So that just basically means wait until we've set it up. And once we've set it up, then you can, once our whole server is initialized, then you run this block of code. You get the cursor, which basically says, I want to start editing the database. You execute a command. This is a SQL command that's saying, I want to create a table called users. And there's going to be one attribute in that table. It's going to be called name. It's just going to be a text field. Then you commit the change to the table. So when you call execute, none of this stuff is actually run. It's just kind of sitting there pending in case something crashes or in case something breaks in the middle of it. When you call commit, the change will go through. And then if the server crashes, which is what this at means, then we're going to close the SQL connection to make sure that we don't accidentally write anything to it, like halfway or anything. So we get the attribute from this G variable. And then if the database exists, if we actually bother to set it up, we're going to close it. This will close the database safely and make sure that nothing's corrupted. Then we've got our standard routes that we had earlier. Then we have a new one. It's a sign up field with name. So this is going to call sign up. It's going to get the database. It's going to execute. It's going to add a new user into the database. So insert into the table users, values, and then this question mark. Now the question mark will be replaced by anything that's in this second line. So since there's one question mark, I just made the size 1 tuple with name as its variable. Commit the change. And then just to prove that it's working, we're going to have this thing get every single user and return it back, just as proof that it actually added us. All right, then we run the app. So let's save that, quit out of it. And we also touch database.database. And you'll notice earlier we had this initDB. Notice this was like never called for some reason. And that's because we only want to call it once. You only want to create this table once. We don't want to have to create it every single time and just rewrite the information. Kind of suck if every single time a person logged into your website, everyone else's data was erased. So we're just gonna from app import initDB. We're just gonna call initDB. All right, let's see if it worked. Sudo python 3 -n, run the app. That's on port 80. All right, let's check it out. Still returning normal stuff. To sign up, and my name is Jack. Nice, just returning that. Does it return it even after I add something else? Yep. Does it add all the users? There you go. So now you have a SQL database. You'll notice the database actually stays intact because if we crash the server, like I just did right there, and add another user, this stuff stays. So it's not in memory, it's saved on disk inside the SQL database. So yeah, and obviously you wouldn't want a sign up sheet to actually return the list of all the users that have logged in. That's just a demonstration to show you that you can. All right, finishing touches. You've also noticed that every time I hit Control-C, or if I were to exit this terminal, the server would crash, which kind of sucks. So this is just a Linux trick you can do. If you append and to the end, first, if you do this arrow thing, also going to say, put it out into the server.log. And this to arrow means reroute all the errors to a file. We're going to reroute them to errors.log. And finally hit and, which means run this in the background. Look, I still have control over my terminal. And if I hit jobs, I can see the stuff that's running in the background. So I've got this giant thing. And let's actually look at server.log. Hey, look, looks like it's running. If I refresh the page, the server's still running. If I check the server log, or perhaps it prints it as an error. Yeah, for some reason it prints that as an error. But yeah, you can see all the stuff is printed here. And I'm just going to go to the index to show you. Oh, there we go. Someone just got slash, and that was me. All right. So now the last thing you can do, stuff that's in jobs will actually crash the second you close this command line. Even though like you can still type other stuff, it will still crash once you log off. So I type disown, jobs is empty, and the server still runs, even though it's not there. Now, that might be a little weird, but you can actually see the server running right there. It's systemd, which means for, you can find the server in here. It's this Python 3 one right here, because we ran Python 3. And if I wanted to, oh, it moved. I just delete it. And log off. And the server will still run. So yeah, that's how you background things in AWS. So congrats. At this point, that might have been a little fast, but you will have a dynamic web server going. Anything you can do with JS, that's up to you. Yeah, but here's some more resources. Flask, Jinja, and SQL all have documentation, obviously. You can find a million tutorials online for SQL, and you can see how to use all the different functions of Flask and how to write these special templates with Jinja. You've got for loops, while loops, and HTML. You can do a bunch of crazy stuff with that. And with AWS, there's also a lot of other stuff on AWS. This thing called Elastic Beanstalk, which actually sets up a web server for you, and it'll attach this thing called auto scaling, which means if you get a lot of people accessing your website, it'll automatically make a lot more machines, so you can have even more latency. So even more people can access your web server without it crashing. Of course, this costs money, which is why we didn't do this. Also RDS, because you'll notice if you have a million machines running a web server, you've got to keep a single SQL database synchronized between them all. And Amazon has a thing for that. You also have this thing called Lambda, which is you'll notice that a lot of our code was really short, really didn't take a lot of compute space. So this Lambda will do really, really fast, single time like run functions that don't need any other information. And of course, with an EC2 instance, you can do anything. It doesn't need to be a Python server. You can have a JavaScript one. You can have a Node.js. That's the same thing. You can have a Django server. You can have an Apache server. Dude, it's really up to you. I just chose Python because that's what I, as a developer, am most comfortable with. And yeah, that's about it.
All right, thank you very much, Jack. We are going to wait a few minutes for questions. Please feel free to go ahead and ask them now, or if you want to ask them later, that's totally fine. Just message me. All of these links will be available in the description of the YouTube video when we publish it later tonight. And as always, of course, you'll be able to come back to this video for reference whenever you need to. So yeah, we'll just wait a few minutes and then we will call it a day. All righty. I think we are good. Okay, well, yeah, as always, if you have questions, direct them to me. Thank you so much for coming. Thank you, Jack, for presenting. Have a great rest of your day and week. See you guys later.